Hello, in this video we're going to go over problem A4 from Putnam 2019. The problem is asking us if there is a continuous real valued function on R3 such that the surface integral of f over s over every unit sphere is 0, but the function is not identically 0. As usual, I'll start with giving you an idea of how to approach the problem, and then we will come up with a solution. So the first thing I'm going to do is to think about, can I make this problem easier, and then see what the answer is, whether it is yes or no, and then we'll get to the actual solution. When I think about this problem, it's a function of 3 variables. So what if we just look at functions of 2 variables or even functions of 1 variable? So what's the equivalent of this in 1 dimension? So I'm going to start with the idea of the solution. So in 1 dimension in R, what we're looking for is a sphere of radius 1, which means basically basically 2 points, and we're looking at points A and B that the difference is 2. We want, like, if the center is x, this would be x minus 1 and this would be x plus 1. So what we're really interested in is whether we can find a function that is not that is not 0, but f of x plus f of x minus 1 is equal to 0. So can we find a function like that? If we think about this one a little bit further, we realize that f of x plus 3 plus f of x plus 1 is 0, which tells us that f of x plus 3 must be f of x minus 1. So it would have to be a periodic function. So f is periodic with period 4. On top of that, we also need f of x plus 2 to be negative f of x. Okay, so we need a function like this. Not very difficult to come up with an example of this function, such a function. If you look at sine of x, that's such a function. However, we need to make sure that the period is 4, not 2 pi. So I'll multiply that by pi divided by 2. So if you add 2 to x, you would get sine of pi over 2x plus pi, which is negative sine of pi over 2x. So this is a good example. This is an example in 1-dimensional case. In R2, we are looking for a function that the integral over every circle is 0. So we can simply choose something similar, maybe sine of pi x. So if you go from one side to the other side, so you go from this side to this side, and then you're coming back, so those two integrals are going to negate each other. So something like that would work. So perhaps the same thing would work in 3 dimension, and in fact it happens to work in 3 dimension as well. Okay, so the answer is no, because the question was asking us, must f of xyz be identically 0? So the answer is no. F of xyz equals sine of pi z is an example of such a function. Okay, so we're going to evaluate the integral of this over a unit sphere. If your unit sphere is centered at a different point, so if a unit sphere is centered at a point x0, y0, z0, it is enough to show sine of pi times z plus z0, which is equal to sine of pi z cosine of pi z0 plus cosine of pi z sine of pi z0 has as integral 0 over the unit sphere centered at the origin. Okay, if you look at this part, sine of pi z, that's an odd function. So surface integral over the sphere, unit sphere of sine of pi z ds, that is 0 because sine of pi z is odd. And S1 is symmetric. S1 is symmetric about the origin. So we'll have to look at the other one, the cosine one. If you look at this double integral, surface integral of cosine of pi z ds, we can take this and use spherical coordinates. Theta goes from 0 to 2 pi, phi goes from 0 to pi, and this is cosine of pi, and this one is cosine of phi, and then rho squared sine phi, rho is 1, so that's sine phi d phi d theta. Now the inner integral is actually pretty easy to evaluate. That is just the sine of pi cosine of phi. If you look at derivative of sine pi cosine of phi, you get cosine pi cosine of phi times negative pi sine phi. So we get this, and this would have to be evaluated from 0 to pi d theta. Plug in and we will get sine of, so it says integral from 0 to 2 pi, we will get negative 1 over pi times, plug in pi, you get sine of negative pi, plug in 0, you get sine of pi, both of which are 0. So the integral would end up being 0. And that shows that this is an example of a function that is non-zero, but the surface integral of this function over every unit sphere is 0. If you like this video, make sure to subscribe to the channel and let me know what other kinds of videos you like. My focus is on preparing students for math competitions. And comment below this video. Let me know what you like me to post about. And I will see you in the next video.